video is titled Mastering Inference, 3 logic rules you use every day. We are Go Mei Ling, Sari Ng, and Teo Yishan. Let's start with the basics. What is logic? Logic is the study of reasoning. It helps us understand whether arguments are valid, sound, and make sense. You can think of logic as a toolbox for clear thinking. It shows us how to go from what we already know to what we can validly conclude. Now, what are inference rules? It is a logical form of guide consisting of premises or hypotheses and draws a conclusion. They work like receipts for reasoning. If the premises are true, then the conclusion must also be true. In this video, we will explore a few of these rules using real-life examples and simple logic symbols. So, let's get started. Now, let's look at modus ponens, one of the most common rules in logic. The rule says, if P implies Q and P is true, then Q must be true. In real life, here's how it works. Let's say P is the alarm rings and Q is our wake up. So the statement becomes, if the alarm rings, I will wake up. Then we are told the alarm rang. Based on the rule of modus ponens, we conclude I woke up. This argument is logically valid because the conclusion follows perfectly from the premise. Now, was this argument convincing? Yes, it makes sense and it follows everyday thinking. Most people use alarm to wake up, so the logic feels natural. But are the premise realistic? The first one, if the alarm rings, I will wake up, is usually true but not always. Some people sleep through alarms. The second one, the alarm rang, is straightforward and easy to confirm. So overall, it's logical, valid, convincing, and mostly realistic. Just depends on the situation. Next, the second rule, disjunctive syllogism. This rule works when we have two possibilities and we eliminate one to conclude the other. The logic goes like this. If P or Q is true and P is not true, then Q must be true. Here's a real-world example. Premise 1. The light is either on or off. Premise 2. The light is not on. So, what's the conclusion? The lights must be off. This is a classic disjunctive syllogism. We are given two options. We eliminate one and logically accept the other. Is this argument valid? Yes, it is. If we know one option must be true and one is false, then the other must be true. The logic structure is correct, so the argument is logically sound. Was this argument convincing? Definitely. It mirrors how we naturally think. If it's not one thing, then it must be the other. Are the premises realistic? The light is either on or off. Very realistic. Lights usually have two states. The light is not on, easy to confirm just by looking. So overall, it's logically valid, convincing, and very realistic. Now, let's look at the third rule, abbreviation. This rule says, if two things are true together, then each one is also true on its own. In simple terms, if P and Q are both true, then P is true and Q is true. Here's a real-life example. I'm a student and I have a laptop. From that, we can conclude I'm a student. It's a natural part of the original statement. If both are true, then each one is also true. Is this argument valid? Yes, this is a classic abbreviation structure. From P and Q, we can conclude P or Q. This logic is always valid, no matter what truth values you plug in. It's what we call a tautology. Something that's always true. Was this argument convincing? Yes, it's very clear and straightforward. If someone says, I'm a student and I have a laptop, it makes total sense to say they are a student. It's just pulling out one part of the full statement. Is it realistic? Absolutely. Students owning laptops is very common, especially today, so this statement is both logical and believable. So overall, it's logical, valid, convincing, and very realistic. Short summary, how these logic rules help us think clearly. Modus ponens help us connect cause and effect. It allows us to make reliable conclusions. If we know something is true, we can confidently follow its logical result. Disjunctive syllogism sharpens our thinking by using elimination. If one option is ruled out, we are logically accept the other, improving decision making. Abbreviation reduces complex ideas into simple symbols like P and Q, making arguments easier to analyze and less mentally overwhelming.